Now we're ready to move on to the next part where we're actually going to start plotting our points. I'm going to zoom in a little bit to make it easier to see. My first point, I'm going to plot negative 48 and 0.992. I'm going to go to my scratch paper. I'm going to write those two things down. I need to know on my x-axis where is negative 48 degrees. I'm going to choose to do this in a little bit different way. On this particular graph, my 0 point worked out really well. It might not work out on yours. So I'm going to show you a way to get around that. Okay, so let's pretend for a moment I don't know where 0 is. I do know something though. I know where negative 50 is. So if I can find out how far is 48 from 50, or negative 48 from 50, well, this is positive 2 degrees from negative 50. So I really need to figure out, well, how many boxes is that? How far is it to get 2 degrees? 2 degrees C on my scale, okay, I know that on my X scale, it's up here, one box is 6.25, which means that 4 boxes is 25 degrees C. This gives me a ratio that I can use to figure out how many boxes it is. 2C, I'm going to get rid of my C and gain boxes. I'm looking at this like a conversion. I know that on my x-axis, 25 degrees C is 4 boxes. That's a true statement. 4 boxes is 25 degrees C, so I can use this to convert from degrees C into boxes. So I pull up my calculator, 2 times 4 divided by 25. And I find that this gives me 0.32 boxes. That is about 1/3 of a box. So I'm going to go in here, zoom in on 50 so we can see what's happening. Here's negative 50. I need to move in 1/3 of a box. So right there is negative 48 degrees C. I now have to do my Y value. The Y value I need on my y-axis, I need to find the value 0.992. Well, I don't know where 0 is, right? My 0 is here, but I have a broken scale. I do know where 0.9 is, so I have to say how far from 0.9. This is 0.092 from 0.9, which is a point I actually have on my graph. If I can figure out how many boxes is that, then I can count from my 0.9 point. So 0.092 meters, I'm going to do another conversion. I need to get this time from meters to boxes. So I need to look at my y-axis. Well, I know that this is true right here. I know that on my y-axis, 4 boxes is 0.025. 4 boxes is 0.025. This is now a conversion I can use to find the value that I'm interested in. 0.92 times 4 divided by 0.025. .72. You can see that we've really exaggerated this scale, right? This is a very small number, but it's way up on our scale. 14.72. So, going to my graph, here's 0.9. I need to go up 14 and about 3/4 boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and almost 3/4. So there's my Y value. Now I just have to find where do these two things meet. I follow up from my X value, over from my Y value, and I place my point, give it a point protector. There is my first value. I then repeat this process for each point along the way. I'll do a couple of more just for example. Okay. I need to plot. My second point is I'm going to skip ahead to the fourth point. So I'm going to find where is 55 degrees C. Well, I don't have a really great spot for that, but I know that this is 5 degrees C from 50. So I'm again using a different reference point. I'm saying I don't have a good zero, so how far is this from something that I do know? I know 50 is right there. I need 5 more degrees to find out where that is. Well, 5 degrees C, we need to get that over into boxes. I know that 4 boxes is 25 degrees C on this scale. So I get 5 times 4 is 20. 20 divided by 25 is 0.8. So from 50, I need to go 0.8 of a box, just past 3/4. So there's the point. I now need to go up on my y-axis. I'm looking for 1.028. I can do the same sort of trick here to reduce my counting. I know that that is just beyond 1.025. This is 0.003 from 1.025. I know where this is. I just don't know how much farther I have to go. So I need to find how many boxes is that many meters. I know that 4 boxes on my y-axis, 4 boxes is 0.025 meters. I get that from my scale. I can do this calculation, and I find that you have to actually hit the zeros. I find that that is 0.48 boxes, or approximately 1/2 of a box. So going to my plot, I need to run all the way up to 1.025, and I need to go 1/2 a box beyond that. And I can place my point. So in this way we can use our ratios to find out exactly where we are meant to place each of our points. We're not guessing, we're calculating and carefully placing each point in the exact right location. I'm going to go ahead off camera and finish this graph so that we can then talk about the next step. I've gone ahead and plotted the rest of the points using the methods highlighted previously, and you can see that we have a linear relationship here. Each point is clearly delineated with a point protector that you may or may not be able to see from this range, but we can clearly see this as a straight line. The next step is to draw the line of best fit. Important things to keep in mind when looking at a line of best fit. You're not drawing a line through any 2 points. No point is more important than any other point. What you're trying to accomplish is you're looking for the line that should be there. Right? We see this as a line, we have to draw that line, the line that our mind knows is there, that these points are approximating. So when you place the ruler, I'm putting it on a side, you want to think about a balance. You want it so that not just have the same number of points on each side, but so that the distances from those points are all balanced out, right, too. So if you have a point that's way over here, you're going to need a lot of points over here to balance that out. Okay, so it's really, you're trying to balance this so that the line is as just absolutely as good as possible. So there's a bit of an art to this. Take some trial and error, but over time we'll get better. So I'm going to place it. Once I have placed this, I'm going to draw one continuous line. I'm going to zoom in a little bit. One line. Okay. When I get to a point protector, I'm going to pick my pencil up. I don't want to draw inside of point protectors, but I'm not going to move the ruler at all. I'm drawing one line that is interrupted by point protectors. I'm using a good straight edge that isn't all ratty and messed up so that I have one single line on my page. At this point, that is the line that I'm interested in working with. I need to find the equation of this line. The data points at this point are there, but we're not going to pay any more attention to those things. As was discussed, so we're ready to move on to the next part. We need to find the equation of this line.